Hello everyone, we're the Brain Cells, and today we're going to be explaining and thoroughly diving into the project of Arduino. We will be teaching you step by step on how to code, how to assemble, and explain each parts and their importance in the projects. In the process, my group mates and me will explain it to you on how it's processed. We have Sir Hans, who will be editing the videos. We have Sir Ace, who will be explaining how the assembly is work and thoroughly strategize. And we have Sir Galib, who will explain the parts and its importance. And me, yours truly, will explain the code and thoroughly dissect it to easily teach you on each of its importance. Without further ado, let's go into it. The Brain Cells presents Project 15 Infrared Control LED Matrix.
First is jumper cables additional mill-to-mill connectors for more complex breadboard setups, and the second is resistor 220, multiple resistors for use with LEDs or input protections, and the third one is 8-segment LED display digits 0 to 9 or characters useful in counters or digital clocks. And the last is IR remote control, sends infrared signals to the IR receiver for wireless control applications.
Hello everyone, my name is John Stephen D. Saigon, and today I'll be the one to explain the code in Project 15. So, at the start of the code, we include the IR remote library so that the Arduino can understand signals from the IR remote. We also declared a variable named receive_pin as 11, which is where our IR receiver is connected. The IR receive object and results variable will help us store and decode these same signals. Next, we prepare an array called codes that will hold the unique hexadecimal values for each button on the remote. These codes will help represent the number from 0 to 9, plus 2 special buttons, 1 to move forward and 1 to move backwards. We also declared the segment pins for the 7-segment displays using seg pins 8, connected to pins 2 to 9. Then, after that, we define digits, a 2D array that stores the on and off pattern for each number. This will tell the Arduino which LED segments should light up to form each number. A helper function named numberShow is created to display a specific number by updating all the segment pins. Next, in the setup function, we start a serial communication with serial.begin 9600 so we can see the button presses in the serial monitor. And then, IRReceive.enable IRin starts the IR receiver, allowing it to listen for remote signals. After that, we prepare all segment pins 2 to 9 as outputs. Each pin is set to low at the beginning so that the 7 segment pins will display off at the start. This will ensure that no random numbers appear before we press a button. Finally, in the loop function, the loop is where the remote actually controls the display. The Arduino checks if the IR receiver has detected a signal using IRReceive.decode (results). If a signal is found, the code compares it with the stored values in the code's array. If the signal matches one of the number, the Arduino calls number show to show that the number on the 7 segment updates with the current number and prints it on the serial monitor. But if the signal matches the back number, the displayed number decreases by 1 unless it's already 0. But in the options, if the signal matches the advance button, the displayed number increases by 1 unless it's already 9. Finally, the hex value of the signal is printed and IRReceive.resume prepares the receiver to listen for the next button.
So now this is the project 15, the 8 segment LED. So this project is controlled by remote. If you press 1, it will show on our 8 segment LED. The components you will use here are 8 segment LED, resistors, jumper wires, IR remote, IR sensor, and Arduino Uno. So we will attach the 8 segment LED first and all of the resistors to avoid confusions and wrong wirings, since one wrong wirings can affect the whole 8 segment LED, so it will not turn on or turn off. So we need to be careful because this project uses a lot of jumper wires. We attach it on the ground section, this section, and 5 volts. So as you can see here, it's okay. Now we will press the number 1. If it will turn the number 1, so it will turn 5, 6, 7, 8,